Okay, today we are going to learn about the first type of problem, that is normal type of problems in projection of planes. Okay, so for that we have the first question. You see the question: an equilateral triangular lamina of 25 side. That means we need to construct a triangle that will be that is having same dimension with respect to all the sides. So with one of its edges on HP. Okay, so here in this question we will be splitting that with respect to each of the positions. So it is telling that we need to construct a triangle of dimension 25 and it is resting on the HP plane with respect to the edge. Okay, we know how to construct a triangle with respect to the edge, right? We know the first position. Okay, so in the first position it is lying on the HP plane and it is starting with the edge. Okay, now you see, proceed with the question, such that the surface of the lamina is inclined to HP at 60 degree. You can see that. So herein the surface of the lamina, it is inclined to the HP by 60 degree. Okay, that's what the first inclination to HP. Now the same edge on which it is rest, okay, the same edge on which it is rest is inclined to VP at 60 degree. That is, you can see that the same edge which has been inclined in the HP, to that edge we are inclining again to the VP by 60 degree. So that's what the condition for normal type of problem, right? If the angle of inclination, if it is there with the edge and the same edge has been inclined both with respect to HP and VP, we calling that as a normal type of problems. Okay, so now we will proceed with the first position. You can see that we need to construct an equilateral triangle of dimension 25 with the side with one of its edges on HP. Okay, so I'm going to proceed with the solution. So if I am showing the solution here, you can see that. So we have to proceed. So I'll be drawing the first position. We know how to construct the first position, right? First I'm drawing an XY line, because in this projection of planes we are going to use only the first quadrant. Okay, remember it. So in the projection of planes we are using only the first quadrant. We are not using the second, third and fourth quadrant. We are using only the first quadrant. Okay, so we are restricting our problems from projection of planes only to the first quadrant. That's why VPHP. Okay, so now you see the question. Our equilateral triangle of lamina 25 is resting on the HP with respect to the edge. We know how to construct a triangle with respect to edge. Okay, so the dimension here 25. So I'll be measuring 2.5 box, that is 25 Okay, I'll be showing the dimensions on one side. So this is 25. Now using the compass we know how to construct a triangle. Okay, I'm going to measure the same 25 dimension. Okay, I'm going to cut the arc from these two positions, from keeping at this point. Okay, cutting the arc. Okay, after cutting the arc, so you can join here. Okay, so this is what the first position, right? So equilateral triangle of dimension 25 resting on the HP plane. So this is what the top, you can see this. We know that the top view it is drawn in the HP plane. So we are writing the notations here. Small notation for a triangle, that is small a, small b, small c. So this is what the top view, correct? This is what the top view. Now we have to draw a front view of it. Say, so we have been placed like this, right? We have been placed the triangle like this, just in order for you to understand the first position, right? We have to draw the first position, top view and front view. So we know that front view will be lying in the VP plane. So in this top view we know that, so we have got the triangle of dimension 25. So if you are looking from the front view, okay, so if you are looking this triangle from the front view, you can able to see only this edge, that is BC. Okay, you are only able to see, if you are seeing from the front view, okay, from the front view you are able to see only this edge BC, correct? Only BC. So what we do to project the front view, so we will be using the projection line here. With the help of projection line, so projection line will be thin line here. Okay, projection line will be thin line, and then the V we will get it on this xy line here. So remember it. So the v which we get will be on the xy line. So now you see we are able to see the end BC, right? So I will be writing B dash C dash, which is visible. But you see, when you are looking from this front view, we are able to see this edge. We are not able to see this corner point. So this A dash will be in the brackets. Okay, this is what the first position. When we construct a triangle, we get the same dimension of 25. So when we project the front view, we are able to see only this edge BC. That's why B dash C dash is written without brackets, and A dash, A which is not visible, that is written within bracket. Okay, so this is what the first position. Now you see the question, such that the surface of the lamina is inclined to HP at 60 degree. So what we have to do here is, in the second position, we have to incline this. Okay, we have to incline it with respect to this HP plane by 60 degree. So when we are inclining this in the second position like this, so we are inclining this the edge B dash C dash. Okay, so this is what the length B dash C dash will be inclined here. Okay, so when we inclining it in the second position like this, so we are inclining this B C end only. Okay, so what I am doing is, so in the front view I am going to incline this line by 60 degree. So that's what we can see in the front view. Okay, I'm going to show the first front view, then I will draw the inclined top view. Okay, for that purpose, first I will be writing this B dash and A dash. This is our reference point. After that I'll be measuring this length. Okay, that is B dash C dash. I'm measuring this length. Okay, so this length I'm measuring it and cutting the arc. Okay, cutting the arc. Okay, cutting the arc. Now we have been already cutted the arc, but we know that we have to incline this B dash C dash by an angle of 60 degree. Okay, by an angle of 60 degree. So what we do here is, so with respect to this point, this B point exactly to this B dash point with the XY line. So I'm fixing this protector and marking for 60 degree. Okay, marking the 60 degree, marking a 60 degree. Now you see that I'll be drawing a straight line here. I'll be drawing a straight line here. Okay, so this is where we got. Now again what I'll do, so I'll be measuring this length, such as B dash C dash. I'll be extending this arc. Okay, extending this arc which I have, that is B dash C dash. So it is been the angle we got here, it is 60 degree. Okay, so after getting this length we will rub it. So this is what the actual length we require here. Okay, till here. So I am going to dark that. Okay, I'm going to dark this length. So this is the length we actually require. Okay, so now, so we have to draw the inclined top view. Say this is inclined at 60 degree like this, so we have to draw the top view of it. How we do that? Using the projection principle. You just follow the procedure, you will understand. So projecting the lines here, projecting the lines downward. Okay, so from both front view and top view on either side, we can able to construct the second position inclined view. Okay, second position inclined top view. Okay, so we have been projected the lines. Now we have to see where the points are merged. A dash, from there is a projection line, and A, these two are merging at this point. This is our A point. Similarly B dash and B, it is merging exactly here. This is B. Now similarly C and C dash, this it is merging here. So now we can join this to construct the inclined second position top view. So now we have done with the inclined second position top view. Now we see the question, the edge on which it rests is inclined to VP at 60 degree. That is, we know that it is like this, it is inclined. Now we have to incline the same edge. We have to incline the same edge. What we do? We are going to incline with respect to VP like this. Okay, we will be inclining like this. So for inclining that, first initially we are going to draw an angle line here. Okay, we are drawing an angle line. Okay, for how much it is 60 degree. So we are drawing for an angle line of 60 degree. Okay, so initially you mark a point here to that point. Okay, to that point you initially mark a point on XY line, then again after that you can mark a point, so that will be easy. First you mark a reference point, then keep the protector, and then you mark a point. Now this is what our angle line. Okay, 60 degree angle line. Okay, so this is 60 degree. So now what we do, we are taking this BC edge like this. So this is what our resting edge, right? AB, sorry, AB, this is a resting edge. We'll take this AB resting edge and we are going to place it like this on the angle line. This is how we can make the triangle inclined to HP. Now it is inclined to the VP. Okay, so you follow the first time you mark a point of A, reference point A. Now we'll be measuring this length AB. So transferring the inclined view here. So inclined top view. Okay, not the first position. We have to project the second. AB, I have measured the length. So take this AB length and you can cut the arc. Okay, so cut the arc. So this is what our AB. So now we got the length AB. Now we have to cut. We have to transfer this diagram on this angle line. So from A to C, first arc. A to C, first arc you have to cut. Okay, then second arc from B to C, it is somewhat same, the arc length you will get. Okay, so this point is C. Okay, so now you join it. Now we join this. Now join this. This is what your inclined third position, top view. Now in order to draw the final position, what we do, we are going to project it upwards using the projection lines. Okay, with the help of projection lines from the side, we are going to draw the final view. Now you see where these two are merging from the top and front view, A and A dash. A dash also here. So these 2 points are merging exactly here. This is our A dash. Similarly B and B dash. So it is merging on the same XY line. So this is B dash. Similarly now C and C dash. These two are merging here, C dash. Now we are going to join these views. Okay, AB we have joined. Now from A to C dash and B to C dash. So we have drawn. You see that. So these views need to be darker. Okay, darker, thick lines. So this has to be drawn with thick lines, and projection line has to be thin lines. Okay, projection lines has to be thin lines, and this has to be thick lines. Okay, actual views. So now you understood, right? So it is like this. So the problem proceed. First position, we have drawn a top view and the front view. In the top view we get the same dimensions, and in the front view we are able to see only this B, C. That's why B dash, C dash visible, A dash will be in bracket. Now in the second position we have inclined like this. That is, we are inclining the B dash, C dash line in the front view by an angle of 60 degree. So that's why we did this one. Then after that we did this position. Now in the third position what we did, so we have to incline this lamina by an angle of 60 degree. So for that purpose, first we have mark and reference point, then we use the protractor, mark for 60 degree, and then we draw an angle line. Then after that we mark a reference point A. Next after that we from the compass measured the length of AB and cut the arc. Then again for arc from A to C and B to C. We have completed the diagram. So this diagram we have used for copying here. Then using the projection lines we have been mark the final view. So how the problem proceeds means, so this is our first view, second view, third, this is fourth, this is fifth, and this is sixth. Okay, so this is how we do the normal type of problems in equilateral triangle. Today we are going to learn another normal type of problems in square lamina. So the procedure it is same, that angle of inclination will be there with respect to the edge surfaces. Okay, now see in this problem is it is a square lamina of 40 mm side. We have to construct a square of 40 mm side, rest on one of its sides on HP. So in this problem also your first position starts from the HP plane, and we have to construct with respect to the edge or the side. Okay, now the lamina makes 30° with 30° to HP, that is inclination of the lamina, it is 30° to HP, and the side on which it rests it makes an angle of 45° to VP. So from this question we can understand that you can see both the inclinations were there with respect to the edge or the side. Okay, the lamina makes a 30° to HP means, so it is inclined with respect to the edge, and then same edge which has been inclined to the HP, it is inclining, making inclination to the VP. Okay, so it is a normal type problem. So first we start with the first position, that is construction of square of 40 mm side with respect to one of its sides on HP. Okay, so first we draw an XY line. So we know that our problem starts with the XY line, and we know that from here onwards we have to use only the first quadrant. Okay, XY, VP, HP. So now we have to construct a square of dimension 40 mm. So 40 mm means it is of 4 boxes. So now we can show the dimension on one side. So it is 40. So now we can mark the namings A, topic A, B, C and D. This is what the topic. So now you have to draw the front view. You know the procedure. So by projecting with the help of projection lines, we get the front view on the XY line. Okay, we get the front view on the XY line. So we are able to see from the front view. Okay, we can see the BC end. So B dash and C dash are visible, but A dash and D dash not visible. Okay, so now we have done with the first position. Now we proceed to the second position. You can see that the lamina makes 30° to HP. Okay, so first I will take a reference point here. So reference point it is B dash and A dash. Now we have to show the inclinations here. So that is a 30° inclination we have to take. Exactly mark it here. So mark for 30° and draw a straight line. Okay. So now we will cutting the arc for this B dash to C dash. Okay, we will be cutting the arc. So this is C dash, D dash. Now we are going to arc this length. Okay, and we can show the angle. The angle here we got it is 30°. Now we have to draw the top view, second position top view inclined view. So projecting downward. So we can draw. So here you see that projection of A and A dash, it is intersecting here. This is A. Similarly B dash and B intersecting here. This is B. Similarly C and C dash, it is intersecting here C, and similarly D dash and D, it is intersecting here D. So now we will draw the inclined top view. Okay. So now we have to draw the third position, that is inclination to the VP, it is 45 degree. So first we draw an angle line. Okay. First we take a reference point here. Okay. To this reference point, we are going to mark a 45 degree. Then we draw an angle line here. So it is 45 degree. So the resting edge is AB. So we have to copy down this AB. So first I will take a reference point A here. Okay. Now measuring the length of AB. Measuring the length of AB and cutting the arc. This is AB. Now we have to copy this diagram. You just follow the procedure A to D. First arc. You see this A to D length, it is exactly equal to B to C. Okay. So after we cut the AD and BC, now the reverse we have to cut from A to C. Okay. A to C first arc. Then similarly from B to D it will be equal to A to C. Okay. It is of same length. So cut the arc. So we get all the points now. This is D and this is C. Now we join it with the scale using straight line. Okay. This is inclined third position. Now we have to draw the final position. So I will be extending the XY line here. Okay. So we're drawing the projection lines. Okay. So now we see this is the projection line from this front view. So now you see where these are merging, A and A dash. So merging exactly here. This is A dash. Okay. So similarly we have B and B dash. So these two are merging here. This is B dash. Similarly C and C dash. So it is merging here, C dash. Similarly D and D dash will be merging here, D dash. Okay. Now we have to complete the final position. So this is what our the normal type of problem in the square. Okay. Now finally we are going to mark all these 6 projections. Okay. Okay. So this is what our today we are going to learn another problem on pentagonal lamina with the normal type of problem. So now we look at the question. So pentagonal lamina of edges 25 mm. So it is so we have to construct a pentagonal lamina of dimension 25, and it is resting on HP with one of its sides. Okay, that means we have to construct a pentagon with respect to the edge on the left hand side. Okay, now the inclinations such that the surface makes an angle of 60 degree with HP. This is what the inclination to the HP. Now the same edge on which it rests is inclined at 45 degree to VP. Okay, so now we have to construct with the first position now. So we know that it is in first quadrant. So we have to construct a pentagon now of dimension 25. So we know that we have to use the protector for angle. So angle it is 72 degree. At another point we have to mark it for 72 degree. Now we have to cut the angle for 25. Okay. Now from this point so after constructing it, so I can remove these parts. Now we can show the dimension on one side. Now we'll draw the projection lines to construct the front view. Okay. So front view it is lying here on the XY line. Okay. Now we'll write the notations. So from the front view, we are able to see B dash, C dash, and D dash visible, but A dash and E dash not visible. Now we see that we have to make such that the surface makes an angle of 60 degree with HP. So for that we'll take a reference here first, that is this B dash, A dash. Now we will be marking at an angle of 60 degree. Okay. So now here carefully we have to cut two arcs here from B dash to D dash and B dash to C dash. First arc from B dash to D dash. That is your first arc. Now second arc from B dash to C dash. Now write down the notation. This is C dash, E dash, and this is D dash. Now I'm going to dark this length. Okay, now we write down the notations. So A dash and A is reaching here, B dash and B reaching here, C dash and C will be meeting here, D dash and D will be meeting here, and E dash and E, sorry, this A will be meeting here exactly. So here's our A dash A, and this is our E. Now we'll join it. So this is the second position. Now similarly can construct the third position. So third position angle of inclination, it is 45 degree. First we are going to mark a reference point. Now to this reference point we will be marking at 45 degree. Okay, now we have to copy this diagram, right? So first I will take a reference point of A. Now measuring from A to B. So this is B. Now from A to E. So this A to E length, it is exactly equal to B to C. So we will cut one arc. You can see that this B to C is exactly same. So now it is reverse. So remember it, from A to C it is exactly equal to the B to E. Okay, so these two lengths, it is reverse. Okay, so this length I have to cut it again. This BC. So these 2 points, nothing but E, and this is C. Again we construct from C to D. Okay. Then okay, this is what the D point. Now we will join all those points. Okay, so we have done with this position. Now we'll project it upward to construct the final position. Okay. So this is A dash, and similarly we have B dash here, C dash, D dash, this is E dash. Okay. So this is what your problem. Okay. Now we will solve another type of problem in hexagonal lamina with respect to normal type. So we'll look at the question. So we have to construct a hexagonal lamina of sides 25 mm resting on one of its sides on HP. So the first position lying on the HP plane with respect to the sides. Now the lamina makes 45 degree to HP and the side on which it rests makes 30 degree to VP. So first we will construct an XY line. So APH. So that means we need to construct an hexagon here. Okay. So 25. We know how to construct the hexagon. So it is 60 degree. Okay, similarly. Okay. So now using compass, we can cut the arc for 25. Okay. So now exactly at this point, again we have to mark for 60 degree. So okay, M25 we already measured. So we are going to cut the arcs. We will join this. Okay. So now we'll erase these things which are not required for us. Okay, now we can write down the notations. A, B, C, D, E, F. So we will show the dimension for it. It's 25. Okay, so we get the front view here. So this is for the front view. So here from this end we are able to see B dash, C dash, and D dash, but A dash, F dash, and A dash not visible. So first we will take a reference point here, B dash and A dash. I will be marking it. So angle of inclination it is 45 degree. So angle of inclination it is 45 degree. So marking it 45 degree. Now we have to cut two arcs here. The first arc from B dash to D dash. Okay. Second arc from B dash to C dash. Okay. This is C dash, F dash, E dash, D dash, and the angle which we get here it is 45 degree. Okay. And this is what our actual length. So now we have to project it downward. Okay, now we have to see the intersection points A, and this is B, this is your C, and this is D, this is E, and this is F. Okay, now we will join this with the thick line. Okay, so now we have to draw an angle line here. Okay, so for that you can take a reference here. So here in this thing, so we can draw an angle line here also, or we can take here and we can draw a parallel line here. So by taking a parallel line here, we can draw the angle line here also. I'll be drawing a parallel line here, so that we should avoid the merging of the lines. Okay, so angle to BPT is 30 degree, so I mark for 30 degree. It is 30. Now this is our resting point. Resting point is A. Now A to B, first arc. Okay, so this is A to B. Now from A to F, your A to F and your B to C, it is exactly same. Okay, now reverse B to F. Okay, this B to F and A to C will be of same length. Okay, so this is our F and this is C. Now from C to D, and F to E. Okay, now again reverse it is F to D. Then from C to here. Okay, so here at this point we get this is E and this is D. Okay, this is what our actual incline be. So now we will project it upward with the straight lines. Okay, okay, we have here B dash, this is B dash, this is C dash, D dash, E dash, F dash. So now we will join all these points. Okay, so this is what your actual problem. Today we are going to start a problem on circular lamina. Okay, so draw the projections of a circular plate of negligible thickness 50 diameter resting on HP. So you can see that. So we have to construct a circle of diameter 50 resting on HP on a point A. That means we need to consider a starting point A here on the left hand side. So on the circumference we have to consider a point. So with its plate inclined at 45 degree to HP and the top view of the diameter passing through the resting point makes 60 degree to VP. So it is one of the normal type of problem. So we have to construct a first draw an XY line. So VP HP. Now we have to construct one circle of diameter 25, diameter 50. So diameter 50 means we have to consider a radius of 25 here. 25 means 2.5 centimeter. So you can write here dia 50. So consider radius of 25 from scale. Okay, so consider it and then draw and circle here taking a reference point. So we have drawn and circle. Now we know that so we have to divide this circle into 8 equal parts. Okay, so for that initially I will be drawing a straight line here. Then we know the concept. So in order to divide the circle into 8 equal parts, we will be considering the 45 degree, right? So as we have been find out in the external angle, so taking this point as a reference, so I'll be marking at 45, 90, okay, then 135, 135, and then 180. Okay, so after marking these points, marking the points, so here to construct you have to draw lines. Okay, so after drawing this we can extend it. Okay, we can extend it, so we can extend these lines to complete the profile here. Now we have done with the construction of a circle, so we have to mark a point A here. You can see that a point A we have to mark here: A, B, C, D, E, F, G, H. Okay, so after showing it, so we have to show the dimensions here. One side we have to show the dimension. It is 50 diameter. Okay, so it is diameter 50. Now we have to draw the front view of it. Okay. So we have done with the front view. Now we have to mark the notation. Okay, from the front view we can able to see A, B, C, D, E. So first I will write those things which are visible: A dash, B dash, C dash, D dash, and E dash. But F dash, G dash, and H dash not visible from the front view. Now we have to mark, we have to take 45-degree angle. So before that we have to take a reference point first. Take a reference point here, A dash. Okay, now we have to mark at an angle of 45-degree. Now we have to cut the arcs. Okay, totally 1 2 3 4 arcs we have to cut from this point. This is E, first arc. Next second arc from E dash to D dash. Okay, third arc from E dash to C dash. Fourth arc from E dash to B dash. Okay, now we can write down the notations. So B dash, H dash, C dash, G dash, D dash, F dash, and E dash. And this is the length we require. So we are going to mark this. This is the angle T, 5 degree. Okay, and rest of the length we are going to erase it. So now by projection principle we are going to construct the second position top view. Okay, so now the important part here is to mark down the notations. A, so the B we get it here. Okay, and the C point we get it here, and D point, and then this is E, and this is F, and this is G, and this point is H. Now after marking the point, so we have to construct an ellipse here. So with the freehand sketch we can construct the ellipse here. So that the curve we get, it has to be very smooth. Okay, so this is how we construct the ellipse. Okay, this is ellipse, this is circle. Now the third position, so it is 60 degree, so making an angle of 60 degree. So for that purpose I'll be drawing an angle line here at this point. So you can draw the angle line like this also and like this also, so there is no problem in it. So the angle of inclination here it is 60 degree, so mark for 60 degree. So angle of inclination here it is 60 degree. Okay, empty level empty level. Okay, So after marking 60 degree, so we will be transferring this diagram over here. Okay, so for that first I will be taking a reference point A to E. Okay, now the thing here is we have to cut the arcs. Okay, from A to H. H, A to H and E to F and E to D. Okay, so E to D. So the 4 arcs we have cutted by taking the one length. Now the arc length we have to take, that is reverse, A to F. Okay, E to D. These two lengths are same. Similarly, we have E to B and E to H. So we can can cut the reverse arcs here. Measuring one length, you can finish 4 arcs here. Okay, so after this we have left with this is HG. Okay, so we have cutted. Now this is H, this is G, this is F, this is D, this is C, this is B. Now, so similarly we have to construct an ellipse here. Okay, with a smooth line here. Okay, so this is how we construct the third position top view. Now for the final position, so we will be projecting the lines here. Okay, so similarly we will be projecting the lines horizontally here. Okay, so now marking the notation is now important. A and A dash, we get it here. This is A dash. Similarly, B and B dash, we get it here. This is B dash. Similarly, C and C, this is C. C, we get it here, C dash. Similarly, D and D dash, and E and E dash, we get it here. F. Okay, F and F dash, it is meeting here. Similarly, G and E dash meeting here. Now H and H dash will be meeting here. Now we have to complete the final diagram by means of a freehand sketch. Okay, so we proceed. That is, it is like a curve, not a straight line. B to C and C to D. Okay, C to D, then D to E, then E to F. Okay, so E to F to F to G, next G to H, and H to E. So this is how we complete the circle problem.